Solving applications by using proportions. So we're going to do two problems. So, first off, I can get this situated. In 2008, about 13 of every 100 Americans lived in poverty. The population at the time was about 302 million. How many Americans lived in poverty in 2008? So you can screenshot that. So remember, 2008, 13 out of 100 Americans lived in poverty. And they want to know how many out of 302 million, if this is the population, really lived in poverty if 13 out of every 100 did. So what we can do is cross multiply. 302 million times 13 is 3,926,000,000 equal to 100x. Divide both sides by 100 and we lose 2 zeros, which means I get x equal to 3,926,000 Americans. 3,926,000 Americans. Quite a bit. What if we were given a second problem involving proportions? So say we were given that, coming up, Clayton's SUV uses 28 gallons of gasoline to drive 500 miles. He has 10 gallons of gasoline in the SUV and wants to know how much more gasoline will he need to drive 400 miles. If we assume the car continues at the same rate, that's key. How many more gallons will he need? So, we know a couple things. We were given that it takes 28 gallons to go 500 miles. So this is gallons, this is miles. And we want to know how many gallons it's going to take to get 400 more miles. But he already has 10 gallons and he needs to put in so much more. We don't know what that more is, so we're going to label it X. Cross multiply, we get 11,200 is equal to 5,000 plus 500x minus 5,000 minus 5,000. 500x equals 6,200. Divide both sides by 500. And x equals 12.4 more gallons of gas. So in total, it would take him 22.4 gallons to go those 400 miles. Well, that makes sense. Roughly almost 6 gallons smaller than 28 to go 500, and 400 is pretty close to 500 miles. And so we'd expect an answer in that ballpark, in the 20s. And this makes the total amount in the tank in the 20s.